So let's look at the current video. I'm giving you a question here. It's pretty interesting to look at the question in this way. I'm not giving you the 2 by 2 matrix. And instead of that, I actually give you the eigenvalues and the eigenvector of this matrix M. And I claim that you should be able to find the matrix M. And let's see how to do it. And please look at my words here. Basically, I'm saying that the first eigenvalue corresponds to the first eigenvector, and the second eigenvalue correspond to the second eigenvector. And anyway, please recall the fact that based on our knowledge on the diagonalizable matrix, because now for the size 2 by 2 of M, we actually have two linearly independent eigenvectors. So we understand automatically that the dimension of the eigenspace of the matrix M is actually 2, which is maximal because the size is 2 by 2. And this fact automatically implies that M is diagonalizable. It is actually similar to a matrix D, which is diagonal. And the diagonal matrix actually has the eigenvalues along the diagonal. So I can list the eigenvalues like this. This one is lambda 1, this one is lambda 2 basically. And if you recall, we can actually understand the invertible matrix P by using the eigenvector. If you recall that, basically P has the columns like the first eigenvector and the second eigenvector. And you can try to do something now. You see, the point is this matrix equation must be correct. We don't know the matrix M. M is something we would like to find, but we actually know P and D, right? And it means what? First, P can be written like this. And by the inverse formula for the 2 by 2 matrix, we can actually write the inverse of P this way. So after finding P and P inverse, and because of the fact that you know the D already, I think we can write the equation down as M equals P times D times P inverse, right? So I hope you see what happens here. So what I've done along this process is I multiply the matrix equation on the left side by P and the right hand side by P inverse. If you multiply like this, please note that this one is identity and this one is identity. It means the left hand side is M, right? And the right hand side would be something like this. So it means what? We actually understand the matrix M based on the diagonalization properties, because we know the P and we know the diagonal matrix and we know the P inverse. And if you do the matrix multiplications now, you would get that the matrix we want is actually this one. And that's the answer to this problem. So let's look at the next problem now. I'm taking the same matrix like the last problem. And we understand it already that such a matrix M has this property that M is actually similar to the diagonal matrix D. And I list all the eigenvalues and the eigenvectors of this matrix. And can you tell me how to find this matrix, which is M to the power 100? M to the power 100 means what? It means basically you have to do the matrix multiplication 100 times, which is a tedious process because there are too many times to do. And are you able to make use of this fact to facilitate your computation for this matrix M to the power 100? And I think we can do something here because we understand that M is written as P times D times P inverse, right? And please look at this equation now. Basically, for each M, we can replace it by the three matrices which are multiplied together, right? So you see, basically, you have to multiply 100 copies together. But if you are feeling good about the associativity of the matrix multiplication, you would notice that, you see, these matrices and the next one is P here. These are all identity now. I hope you can see that because I'm just multiplying P inverse times P. So it means the next step is gonna be P is the first matrix, the second matrix is the diagonal matrix. But you see this one becomes identity, right? And this D is here, and the next one is also identity because it comes from the matrix product P inverse times P. So basically you're having something like that. And basically until the end is P inverse like this. And please look at how many copies of diagonal matrix you have. I think basically you have 100 copies of the diagonal matrix D, because you see D actually occurs in each bracket, and we have totally 100 brackets, right? So it means we actually have a nice equation. M to the power 100 is the same as P times D to the power 100 times P inverse. So why am I interested in that? Because it really facilitates our computation for this. we can skip all these tedious matrix multiplication 100 times because of the fact that we now only have 3 matrices, and the middle matrix is so easy to find because if you recall the D is actually this matrix, and the diagonal matrix has the special property that and when you take the matrix multiplication, you just have to multiply the diagonal entries on the same position together. So you're getting such a matrix. So it means that the m to the power 100 is actually the same as. So you see, basically, if you do a matrix multiplication yourself, if you multiply it out on your own, you will get this matrix. I'll just write down the answer here. I trust that you're able to do the matrix multiplication on your own. So you can check, actually, my matrix computation should be correct. And that's the end of this video.